two identical cells two identical cells of EMF 1.5 volt each of EMF 1.5 volt each joined in parallel provide supply to an external circuit consisting of two resistances of 17 ohm each. 17 ohm each. 17 ohm each joined in parallel. A very high resistance voltmeter reads the terminal voltage of cells to be 1.4 volt. Calculate the internal resistance of each cell. Two identical cells of EMF 1.4 volt each joined in parallel provide supply to an external circuit consisting of two resistances of 17 ohm each joined in parallel. A very high resistance voltmeter reads the terminal voltage of cells to be 1.4 volt. Calculate the internal resistance of each cell. First let us understand what is given. So here we are given with two cells with some internal resistance and they are identical cells. Each has 1.5 volts. There are two cells. .5 volt and some internal resistance R. Another 1.5 volt internal resistance R. It is they are connected in parallel and then it is connected to an external circuit which also consists of two 17 ohm connected in parallel. Seventeen ohm. So this is the case. Now we need to find out what is the internal resistance R. Now we will reduce first this into a simple circuit wherein we have one voltage source in series with the internal resistance and the external load. If we connect here, the loads are connected in parallel. So there first you can find out what is the equivalent resistance. 217 ohm connected in parallel will give you the equivalent resistance as 17 by 2. Which is equal to 8.5 because it is 17 by 2. 8.5 ohm. And when we have two identical cells connected in parallel, the resultant source, one single source, will have this 1.5 volt, and their equivalent resistance will be R by 2. Two R's connected in parallel will give you R by 2. So this is equivalent to this. The given circuit can be replaced by one voltage source in series with R by 2 and 8.5 ohm. So in this type of circuit, we have the relation between the internal resistance. If this is, let us take this as external resistance R, and this is E, and if I is the current, then we have the relation between internal resistance, external resistance, and the PD across V is the potential difference across the EMF of the cell. So R is across the voltage source, or it is also equal to capital I into R. So R is E divided by V minus 1 into R. So we can use this equation to find out the internal resistance. Now here in our case, given the EMF of the cell as 1.5 volt. Similarly, given the terminal voltage of the cell when we connect a voltmeter, high resistance voltmeter, as 1.4 volt. Also the external resistance is 17 ohm. Two resistances, 17 ohm. Now let us substitute these values and we will find out the value of the internal resistance. Substitute all the values and find out. So this R is, the relation between R and capital R is actually obtained by the basic equations. If you want, I will just tell you how did we get this equation. For this type of circuit, for a series circuit, I'll write here. Let me just highlight how did we get this equation. R, and this is E is the EMF of the cell, R is the internal resistance, let I is the current flowing through the circuit, and V is the potential difference across the cell terminals, or it is also the voltage across the load R. So for this circuit I can write I as equal to E divided by R plus R. And I can also write V is equal to I into R. Now substitute the value of I in this equation. So we get V is equal to E divided by R plus R into capital R. Now simplify this. R plus R will be equal to E divided by V into R, just cross multiplying. R plus R is E divided by V into R. or small r is equal to E divided by V into R minus R, or small r, the internal resistance, is equal to E divided by V minus 1 into R if I take out the external resistance R value outside from the above equation. This is R is E by V minus 1 into R. So this is what I have written here. R is E by V minus 1 into R. Now substitute all the value, you will get the internal resistance of the circuit. R is 1.5 divided by 1.4 minus 1 into, and remember in our case this R is actually now R by 2. So we can also write here R is, in our case it is now R by 2 because we have two cells connected in parallel, R by 2. So this value is actually R by 2 equal to so this here R is, here it is R. Similarly for our case R value is R by 2. So R by 2 is 1.5 divided by 1.4 minus 1 into 8.5. Do the calculation and find out the value of R. So R comes out to be 1.21 ohm. The internal resistance of the cell is turns out to be 1.21 ohm.